Welcome to week 3. This going over chapter 4, conditions and recursions. Um, we're going to be going pretty fast at this time. As you can see, we have about 9 different things to really go over. Well, 9 different coding sections, and we will just start from the beginning. Um, the first, what we have right here, chapter 4 goes over modular operators, which I think I've been over some of it. Basically, what it is, we're talking about this right here, which is our percent sign, and in C++, the percent sign does not mean percent; it means the remainder. So anytime that we're using dividing by something and want to see the remainder, or just want to have the remainder of something to see if it goes into something equally, and then we do something else, uh, we will go from there and use our remainder or modular, and then we can see if it divides by something and then goes from there. So what we got, I've already put in our information from the book, which is int quotient 7 divided by 3, and int remainder we have 7 module 3, and that's how it's read, 7 module 3. So what we're going to do is just add some output here, and we'll output both the quotient and the module or the remainder. Let's see, and then let's see out remainder. Okay, so let's go ahead and save, compile, and run this. We'll call this section 4 underscore 1 4 dash 1 dot cpp, and let's see how this compiles. And as we know that since we have it in the integer format, we will only have the what's in front of the decimal. So 3 goes into 7 2 times, and we have a remainder of 1 left over. So, and this is showing that we have our 1. So as you're writing this code, you can put in your different variables or different numbers inside there, and you can see your output of what you want to get. Now in section 4.2, it really goes over what the chapter is talking about, or start going over what the chapter is talking about. And this section is starting in the condition executions. Now with the condition is a form of a branch or selection. With that being said, it's telling us that we can do something upon something being happening. For instance, what I like to use is you're driving down the street, you come up to a traffic light. Now, if it's red, you stop. Else, and these nowadays, if it's yellow or green, you keep going. So we're only going to look at the we only at that point look at the red. So if it's red, we stop. Now I'm going to go back to the traffic light and actually work around the other different ones as we go down, because the first section in 4.2, it only talks about one if something, do something, otherwise do nothing. And this is what we have right here. So this is not a full running program, because obviously we have to actually set x to something. In this case, we can have it as an integer and set it to just about any number that we want to be. And matter of fact, we will do that, and we will see in both cases we have right here. And in this section we will talk about comparison operators, and you must learn and know how to use comparison operators um, or it will be incorrect coding. So we'll get back to that in a few minutes. So we look at here. Alright, let's go ahead and have it for we can satisfy it. So we're going to say int x equals, and we'll use a number greater than 0, 1. So let's run and save, run and compile it, or save, compile and run it. So we have what we call this section 4-2.cpp, and we have it coming up now, and we say x is positive. So that right there, x is positive. Now let's say x is 0, because if you look in your condition comparison operator, excuse me, that you will notice that if we have only less than or greater than a number, it is not including that number. Now if we had x's greater than or equal to 0, then we would include 0. So right now we're not including 0. So we're just going to see how it is with 0 and see how it is without 0. So let's go ahead and save it or compile it and go ahead and run it. And as you see, nothing comes up because this is a if something else, it doesn't matter what else, because we're only working with the if. Now these are not traditionally ideal programs to write because you have no check and balance in these. So let's do one more, and let's do a -1. Compile it, run it, and also, like I said, because we don't have equals to right here, greater than or equals to, it doesn't include 0, so it does the same thing as the -1, does nothing. Okay, let's move on to the next section, which is alternative executions. Now, with alternative executions, what we're talking about here are having more to do. So let's go back to the traffic light. If red, stop, else keep going. Okay, so if it's red, stop, else keep going. Or you can do it another way. If it's green, keep going, else stop. Now in this sense, that we have some kind of checks and balance, and it's this is starting to be ideal. Now we use this only if we have two different outcomes. Either we're going to have one thing if it's something, or something else. So look at the coding carefully. We have if, excuse me, and then we have else. So we have two outputs right here. So in this case we have if x has a remainder of 0. So if x divided by 2 equals 0 for the remainder, then we're going to see out x is even. So we know that anything that if we divide any number by 2 and get a 0 remainder, it is even. Now before we go on, two things that we have to look at, and let me separate it out. We have two equal signs right here. Now the two equal signs mean that we're comparing something. The one equal signs mean that we're actually assigning something to something else. Now remember that when we're comparing something in the if statement, if we have equal, we have to use two equal signs. Also notice that in our else statement, we don't have anything in a parameter. So else doesn't have to use a parameter, because this is what we call our quote unquote our default statement. Now, if you read in other sections or other books online or something like that, it will show you, which I didn't go over in the other section, that if you have only one line of coding, you have to use the brackets or braces or whatever they're called. However, I do require you to do this. And the reason why is because sometimes our mind, every time we're working on small individual problems, which does not require a more than one statement. However, if you're coding more than one statement, which will have several lines, you see out something, do something, see out something, you will have to have these. So our best practice is to go ahead and use our brackets, braces, whatever they call it, and just continue working with it in that way. So anytime that we will have more than one statement, it will be automatically that we will use our brackets and braces. Now, going back, as we see, else, if it's this, do something else, do something else. So let's actually set x to equal something. So we'll say int x equals, and we know 2 divided by 2 is 0. So we know the outcomes of this. It should say x is even. So let's go ahead and save this as section 4-3.cpp. And there we go. X is even because x is 2. 2 divided by 2 has a remainder of 0. Alright, now let's go ahead and let's try 0. Just for instance, we cannot divide by 0, but let's see what our output is going to be. X is even. So 0 divided by 2 is 0, with the remainder 0. So that's what we have. Now let's try 1, and we know this is not going to come out even. So let's save that, run that, and I think I put off. However, it should be odd. So we know that the section, or that it checked, it checked to see if it's this. If it's not this, it automatically goes down to this. Okay? So when we're working with different things or different problems, you have to read it carefully. Now, if it says if it's this, then do something, which this is the something else, do something else, then this is else, then we're doing something else. Okay, let's go to the next section, which we've learned, section 4.3 still. We learned that we can actually move this to our as another function. So let's look at this. This is what we did. We wrote our coding, our shell, we have our header, and then we have a void function right here. In our void function, we have a value of int x. So this variable right here has to be the same name as this variable. We should do it for best practice. And we come down and we have the same coding as we did. Now in our main function, what we did was we called that function, and we had, what we did was we have a number, or our value. This is our value inside. So in our value, what we're going to put through is 17. Now we know that 17 divided by 2 will have us a remainder of something other than 0. So we know it should be odd. And I did a little copy and paste. So we have odd right here. Now, in the book, as you read down, it's telling us not to, in our main function, declare a number equals 17 and say call our function and have the int number inside. That is not how we do it, because the compiler already knows that what 17 is because of right here. As as we look at it, we know that it comes in, it has to be an integer value. We do not write it as declaring a number and then have 17 and all that, and this for and this for. Okay, so let's go ahead and save this one and run it. We'll call this section 4-3 continue.cpp. Run it, save it. Oh, we have a problem here, and my spelling is bad. Remember, if your spelling is bad, it will not work. IOString. So let's go ahead and save that. Go ahead and run it. So x is odd. So if you see right there, x is odd. So let's change this up and put a random number, and yes, I think that's short enough. Oh, this is a little too long. I can take out some of these. Let's run it again. Now it's just fine. And we have even. Now when we find a remainder, we always know if it's a odd number at the end, it's odd. If it's an even number at the end, it's going to be even. We can also change up different things, as in we see if it's divisible by 3. We know this is not divisible by 3. Let's put a 9 right there. We know 9. But let's see if the whole number is divisible by 3. Compile it. Let's run it. And we say odd, even though, so we know it's not divisible by 3. That's just a way of actually checking things and see if they're divisible by something. You can always use this in a math class, or use this in some other different ways. Alright, let's go on to the next section, which is chain conditions. Now, let's go back to the traffic light one more time, and we have, as we know, we have 3 different lights: red, yellow, and green. So if red, stop. If yellow, else if yellow, slow down. Else green, go. Now with this green, we're always, that's a just do something else, our default, because we as we're driving, we're always wanting to go, so we use at the top. If the light is red, stop. Else if the light is green, the light is yellow, slow down. If it's not green or if it's not yellow, then you just keep going. Okay, so, and that works in this case here. If x is greater than 0, we're going to say it's positive. If x is less than 0, we're going to say it's negative. Now if it's not positive and not negative, then x has to be 0. So we look at it in this case. Now, also with this, I would also like to go over the flow of it. Now, if we look at this and say what our number is, we say if x is, say 1, No, let's look at it a little different. We'll look at 0. We'll say, is x greater than 0? No, so this doesn't work. Else if is x greater than, less than 0? No. So we have to look at it as this right here. Now we can also look at x. If x is a letter, it'll work as x is 0. Now that's a downfall of this. However, that's the outcome of it. So let's look at it and let's put a number in here. Int x equals, and we're going to say 1, 0, and 2. So we have 1 right here. Let's save and run it. We're going to call this section, of course, 4-4. We're going to actually spell this right first. 4-4.cpp. And we have that. If you're going to copy something, make sure you copy it correctly, or you will have trouble all the way through as I do. And we did not put our semicolon right there. So let's go ahead and say this, run it. And we have x is positive. Okay. Let's see. Let's put another number right here. Let's try 0. Compile it. Save it. Run it. X is 0. So it said nope. X is not. X is not greater than 0. X is not less than 0. But x is 0. So that's conditions that we look for. Alright, now say -1. Compile, run, and save. And we have an x negative. Now, let's try and see, because this is a newer version. I just downloaded it when we first started. So let's change everything. Let's see, char. Let's use a char variable. We're going to actually use that same. We're going to use a char data type. We're going to use the same variable as x, and we're going to say equals to, well, equal to, and we have to do it in single quotes, a. Let's see what it pick up. Yes. Now it says x is positive. Why? It's because a has a value in the computer. I'm not sure what that value is right now. We can actually change our values and see. I'm actually going a little ahead, but however, I do this in class all the time. Int, we can see out int x. And if I'm not mistaken, this will print out our key value of x. So let's, before that, let's do a cout and L. And like we said, this is just trial and error. Oops, we have it already running. So we want to save it, run it. So our lowercase value of a has a positive outcome because a's value is 97. That's our ASCII value. Each letter has a value. You can actually just look it up and see how it is. Matter of fact, this is week 3, and if you notice that every 2 weeks you'll have a test. In week 4's test, if you come up, what I would do is put in the test and ask you what is the value of a, ASCII value of a, SCAII if I'm not mistaken, and you get a number 17, that'll be an extra 10 points on your test. So thank you for watching these videos, and let's go ahead and move on. Alright, our next section is the section 4.5, which is our nested. Now I left this one blank because this is somewhat tricky, but once you get it, you really understand it. Now, we write out everything just the same. This is our shell. So in these values, what we have here, and I'm pulling directly from the book because it shows a little, it gives you hands-on on what we're doing, and you can look side by side. So we say if x equals, which is two equal signs, 0, and then we come down and if 0, see out what x is 0. That simple. Okay, now it also tells us to do something else. Else, then we have else if, and this is where our nested comes in, x is less than 0, greater than 0, then we do something, then we see out x is positive, if I can actually spell it correctly, and if it's not positive, then else, then we have our statement here, see out x is negative. Now this is doing the same thing that we did beforehand. However, it is a it is a nested loop. So let's really look at it and go over it. So we have x is equal to 0, then we're going to say that it's 0. Now, if x is not 0, and it doesn't matter if it's 0 or not for this particular part, if it doesn't matter if it's positive or negative, if it's not 0, it's automatically going to go down to the else. So when it goes down to the else, then it looks at it as if it's going to be greater than 0 or is it going to be less than 0. Now in this else case right here, which I have highlighted in blue, this case right here is looking for, or will not accept 0 as an answer because it's already been checked in this part. So when it looks down here, we have our if, and then we get to the if it's greater than 0, it's positive. If it's less than 0, it's negative. Now, also I want to mention and look at, and I see that we're actually going to be going over the 30-minute mark for this video, where I want to iterate that if you have the version 5.4.0, which is the same thing that I have, it will automatically put the parentheses and the braces, brackets, whatever they call it, in here, and that right there, it tells you what's inside of what. So what's inside of this is only this. Now what's inside of the else, the big ones, is the if and the else. So we can do it like that, and it helps you out. Sometimes it's a pain because if you miss some, in some cases when you're writing a program, it will not stop it where you need it to be and then it keep going, or it will stop where you don't need it to be and not keep going when you need it to. So remember your ending and closing brackets or braces. Now, just for giggles, we're going to run this, and we know it's going to do the same thing. So we call this section 4-5.cpp. Up. What happened? We did not declare x. So let's go ahead and declare x right quick. We'll say int x equals, and we're gonna say 522. Now let's go ahead and, oh, we forgot our semicolon. Let's go ahead and run it, save it. I have a couple of errors right here, so go ahead and fix those. And we see that we have x is positive, which you know 522 is positive, so that's what we get. Alright, now going on to the next section, we have two more sections to go to. We have the returning statement. Alright, in our returning statement we see that we are using, and yes, in a return statement, what this does is stop the program right there, where the return is going. It's going to flow down from line 9, line 10, and 10 says return. That's where it's going to stop, instead of us stopping in our actual main function. And what I did leave out is the return 0 in the main, to show you that the main has returned 0 because that means something is correct. In our void, if you look at it and it says if x is less than or equal to 0.0, then we see out positive numbers only. So this means that we're doing a log. When we're doing a log of something, we have to have positive numbers only. And if you put a negative number in there, it's going to have a mistake. So we show that, okay, it's going to output something, and then it's going to completely shut down the program, and in order to fix it, you're going to have to actually put in a positive number. So let's run it with a positive number, see if it runs correctly, and then we come back with a negative number and see what it does. So we're going to save this one as section 4.6.cpp. Hopefully we have something. We're looking for results. Function int main. Let's see. We have oh, we're missing something. Log is not declared. We have log is not declared. When we use log, we must learn that we have to have the CMath header. So good at looking at, and we forgot our put in, that's not in the book. Alright, then we run it. Now log of x is or log of 12 is 2.48491. So you can actually do that calculation and see if you want to. We know what 10 is. I think we actually looked up that before section, and we should get, yes, there we go. Now let's put a negative number right here and see what our output will be. Alright, here it goes. Because we wanted to make sure that it does not go any further, because we have it right here, it does nothing, but it'll return into our back into our main, and we don't want it to do it. We just want it to stop right here because it's negative and we can't use a negative. So we have an output positive number only, please. So, and then it stopped. Okay, so let's go on to our next one, is the recursion, which is somewhat simple. and recursion is only telling us that we can a function can call itself. Now that may seem kind of odd at first, but it's actually simple. It's saying that okay, it's doing a loop, which this book, as in this chapter, which I'm not sure why it only goes over the if. I guess because that's the simplest. Um, and for right now, I'm only gonna go over the if statements. If time permits, I will actually go over more condition type statements such as the case, um, and also switch. They are very important when working with other different elements, especially when you're working with the alphabet. Um, but however, you can call a excuse me, lost train of thought. If you're having a function, if you have a function, that function can call itself. Now, this is not a complete program. Our last program was a complete program, and then we'll be finished. But I wanted to actually look at the breakdown of it right here. So we have void countdown. Countdown is the name of our function, and it's going to be a inserted an integer value, and the variable is n. So we're going to use that n. If n is equal to 0, we're going to display blast off. So we think in our minds, okay, our input is going to be blast off. Now, if it's not 0, we're going to actually go down and say cout and then that number. So we have 10. So 10 is not 0, so we're going to just display 10. Now, in our next line, what we do is call the function again. However, when we call it, we're gonna minus 1 from it. So if we have 10, the next number next time it's being called is gonna equal to 9. So we kind of keep counting down. So as we know, negative one, minus 1, or we can actually, I'm not sure if we can actually put n negative negative, because we know that negative negative is a way of saying minus 1, so we're going to actually try that. Alright, it's going to keep going down until n is equal to 0. Now, my question is, will n ever be less than 0? No, because when n is 0, it's going to continue right here, and then it's going to go down to our main function. And then if something else happening, then it would go from there. Now, before we continue on inside our entire program, we're going to skip a little bit to section 4.8, and then that's where I want to stop. I'll let you read the rest. It's called infinite recursions. Now, and with the infinite recursion, if we ever start at negative 0 and we're always a negative number, or start less than 0, negative 1, we will always never, now I know this sounds weird, we will always never hit 0 because it's always minus, so it will continue going for an infinite amount of time. So let's look at it. We have well, what we did was go ahead and put the other one back, the print the logarithmic. Then we have our countdown right here, and then in our main we have 3. So thinking about it, we kind of know what we should have in our output. So let's go ahead and save and run it. Let's see, this is section 4-7.cpp. All right, and actually we did not call I see that we did not call the a print logarithmic, so we can just throw that in here later. But however, let's just look at the countdown. We have 3. 3 is not equal to 0, so it's gonna print out. Then call it again with a -1, so it's gonna be 2. Then 2 is not equal to 0, so it's gonna come down there and print 2. Then call it with a 2 minus 1. So 2 minus 1 is 1. 1 is not equal to 0. It goes down again and print 1. And then it's gonna call the function. And then 1 minus 1 is 0, so n will be 0 right here. N is equal to 0, so it's gonna say blast off. Okay. So if you want to go ahead and make this actually look correct, so we're going to say print mimic, and then we're going to let's put that number 3 right there, and let's see. So 3 is greater than or equal to 0. We're going to have a positive outcome, and let's go ahead and put the inline right there to kind of make it look a little better. So we know 3, 2, 1, but we also get the logarithm of 3. Now, if we put -3 right here, what do you think will happen? Now, what it does, and I think I was wrong at something, so pay attention and always watch to the full extent, that when it stops right here, it automatically returns to the main. I think I said it didn't at first, however, that was a mistake. So it does in the main, it goes here and says, okay, that's wrong, let's do nothing. So it returns down to the count down function. So it calls the countdown function, does what it needs to do in the function, and then it is completed. Alright, as usual, if you have any questions, feel free to email me. I try to check my emails as many times as possible. If you have other further questions, you can always go into the collaboration just under the Q&A and put your questions there. Please remember, do not wait till the last minute to do your assignments, because if you don't understand them and you're doing it at the last minute, if you don't turn it in on time, you will have a 0. So please do it early. Thank you and have a great week.